All right. Hello. Welcome, everyone. We are doing this is I've lost count, number 12 deep dive out of 16 for the 2022 summer internship. And I'm June Bea, CEO of Bea Group. We're so excited at Bea Group that this is our 7th summer running internship programs. We spent the first 4 years doing in person. And then 3 years ago, because of the pandemic, we decided to do virtual. So now all of our interns work from home, and they've been doing this for the past six weeks. And in those weeks, we have done onboarding. So the first week, they became Bea Group employees. They got email addresses based in Microsoft Office 365. They had sessions about communication mastery, about leadership. And then every week, they've been having social justice in the workplace sessions. And in addition to some of those, we have industry professionals who are mentors and deep dive leads. And as I mentioned, we had 16 different topics. So today we're so fortunate to have CRISPR with Michael Friend, who is with the Minority Coalition for Precision Medicine. And so Michael, thank you for joining us from the East Coast. Hello.
Hey June, how are you? Glad to
So
be here.
good.
Yes, absolutely. We were just saying how fast these 4 or 5 weeks have flew by, and so I'm excited. I'm Michael Friend, the founder and president for Minority Coalition for Precision Medicine. And so for this session, we really focus on uh, huge events. I call them huge events we plan on having around conversation around CRISPR. And so what you're going to hear tonight is you're going to hear, or this evening, you're going to hear from two teams, individuals who work on CRISPR Uncut, which is a virtual conversation, but panel-led discussion. But the difference is this conversation is being led by young folks, youth, and interns alike that will be leading these discussions. And you also, there are tentative dates we have set for September for the CRISPR Uncut. And for also, we had a group that worked on Career Day, which is an event that really focuses on bringing companies together and key stakeholders in the industry that will share their experiences around CRISPR and the many opportunities there. And so these young folks work on these two events, as well as they, from four main topics, they chose a topic, whether it was a political implications of CRISPR, the social, the ethical, and the commercial. And so you're going to hear from each of them as to what their thoughts and their perspectives is on each one of those areas. And so thank you all for joining us. And I'm so excited to hear and to see what the interns have come up with in their presentations. Thank you again. And we'll be starting with Team CRISPR Uncut, which was led by Daniel and a few others. And so we're ready to go.
Thanks, Michael.
All right. And so we're going to call on CRISPR Uncut, which is led by Daniel, and Daniel and his team will be sharing the screen. Thank you, Daniel.
I can start us off. So hi, my name is Timothy Alamo. I was one of the team leads for the CRISPR Uncut. And my experience so far, it's been really, really impactful. I've kind of helped Michael and Aleda kind of do kind of the minor jobs. So if anything was, if anything needed to be written up or any emails needed to be drafted, I was in charge of that. I kind of helped communication between the interns. So I made a big group chat and we were trying to keep up with reminders. I was working with Christian and Daniel. And yeah, I'm on the political aspect, so you'll hear me talk in a little bit, but I'm gonna pass over the baton to Christian.
Okay, so we are on CRISPR Uncut team, and we are a group of student intern group focused. Our goal as a team is to create conversations in all levels, including students, parents, and educators about what CRISPR is. So one of our other goals is to create equitable knowledge and an understanding of this new innovative technology to not leave anybody behind when it comes to the next steps of precision science. This is a brand new science, and we don't want people who need it to be left out of this conversation. So in order to have this conversation, we really need to understand what CRISPR actually is. So CRISPR stands for clustered regularly interspaced short palindromic sequences. So if you look in this diagram to the right, on the bottom, you see a strand of DNA that is commonly found in life. There are two parts of it, spacers and repeats. Repeats are what CRISPR is, the palindromic sequences. They're usually blank and they're fillers. The spacers are actually genetic components that our body uses and replicates. So about 10 years ago, Jennifer Doudna, the founder of CRISPR and Cas9 technology, was able to find out that bacteria, when a bacteria infects a cell, it cuts out a piece of the DNA and inputs it into our sequence, therefore making our body immune to that virus. So through Cas9, scientists have the ability to input new genetic sequences into human genomes. By putting new desirable genes into Cas9, we'll be able to cut out and input genes into human genomes.
So what actually is CRISPR Uncut? This is the name of the event that we're going to be holding, as Michael mentioned, in September. The goal of the event is to be a panel that is led by students. The panel is going to be talking about 4 different topics: the social, ethical, political, and commercial aspects of CRISPR. And we're also going to be touching on its future implications. The event is going to have speakers, open Q&As, and also lightning talks, talking about some of the careers and the jobs some of our professionals have. Our goal of the event is to practically make the community more involved and understanding of what the topic of CRISPR is and how beneficial it can be, and while its important future. Sorry. I think, well, our group thinks it's really important to take control of this conversation early on, since we are the new generation and we can be the new scientists and the people who are going to lead this conversation into making it like public domain rather than things we see now as privatizing and kind of commercializing science. So I'm going to hand it off to our first speaker.
Hi, my name is Kimberly Lopez, and I am a part of the social aspect group for CRISPR on the CRISPR Uncut team. So the unique idea of how society can impact the perspective of CRISPR is crucial because these are the people who are going to be receiving this treatment. And this new technology to modify genetic DNA is a newer discussion topic in society. And with the usage of social media platforms, we are able to spread the word of CRISPR and spread awareness of what CRISPR is. And through this action, the audience is able to build confidence and they are able to familiarize what CRISPR is and how it could create a positive intake. And on the left, we could see a woman, and this woman is Victoria Gray. She is the first person to be publicly identified to receive CRISPR for genetic disease in the United States, which caused her to cause a genetic mutation, which resulted to sickle cell disease. And this procedure was successful, causing her to not spend any time in the hospital after her 2 years of treatment. And Victoria Gray is just an example of how CRISPR is one of the examples of how CRISPR has caused a positive impact in society. And she is also an example of what CRISPR can reach its full potential towards curing these diseases and illnesses. And what is so authentic about CRISPR is it's designed with help and with a lot of experts in the field, and they also put their input. Thank you.
Hi, my name is Melanie Longoria, and I will be presenting the social aspects of CRISPR. My first paragraph is titled How Will CRISPR Impact Society? Meaning like how society would be impacted once CRISPR is like really implemented. CRISPR has the power to improve society and help struggling communities. One way CRISPR can be positive to society is it can create vegetation that lasts much longer and can sustain in a variety of weathers. CRISPR can help people with rare diseases by creating personalized treatments for the person. CRISPR can help so many people and families struggling with sickle cell anemia and hemophilia. CRISPR has the potential to help with several different types of cancers. These positive effects CRISPR may have on our society will bring medication costs down, bringing pharmaceutical costs down wherever CRISPR is being used. CRISPR could also have a negative impact on society. One of the negative impacts is making cuts in the part of the genome can actually result in a mutation that raises cancer risks. Another big negative effect CRISPR may have on our future society is we can remove diversity from communities. And what I mean by this is like when you are removing so many different parts of like who you are, for example, like when designer babies comes in, like when you're trying to enhance features that like are physical, that's when like we are removing the diversity from our society. When we're removing these negative genes from DNA, we're removing the range. There's been people that define themselves from their diseases. Some people enjoy being who they are no matter the adversities they face because of it. My next paragraph is about the importance of sharing CRISPR. The sharing of CRISPR is so critical because society can either view it positively or negatively, depending on how we speak of it. The view and understanding communities have on CRISPR is important because that's how it will be shared. If we only discuss the negative outcomes CRISPR may have, for example, removing diversity and equality from our humanity, people will be pushed away from CRISPR being put into our society. But if we speak of all the amazing things CRISPR can have on our society, people will be drawn to CRISPR and more comfortable with the technology being used. Having events that share different aspects of CRISPR is amazing because it gives wide audiences the chance to understand how revolutionary CRISPR is and how it would change our society once it is implemented. And I put in an image of potential applications CRISPR can be in treatment of for different medical diseases. So yeah, that is my presentation.
Hello, my name is Freddie Rauda, and I'm part of the social aspect for the CRISPR Uncut team. Let me just go over why I chose the social aspect. Um, I feel that the social aspect really encompasses, how this change, how this medicine of CRISPR is going to really impact the people. And I feel like that's the most important part of medicine is how it will like change and affect people's lives. So quickly, my focus for my presentation is going to be how different social groups are affected by CRISPR. And by that I mean how different social groups will have like their availability to CRISPR will be affected. Um, CRISPR is experimental technology, so it's currently very expensive, upwards of, millions of dollars. So, the socioeconomic, uh, space or spot groups is in will directly impact how available CRISPR will be to them. Quickly, the Federal Reserve actually reports that people of color are genuinely in a lower income bracket than white people in America. So, like already, they are less likely to be able to afford CRISPR. And then another thing is their healthcare and their insurance. Colored people tend to be like less insured, privately insured, than white people. Um, and they usually fall under either uninsured or government-funded healthcare, meaning that their insurance wouldn't cover this procedure. And that's actually very unfortunate because black people are actually at a really like much higher risk to get sickle cell anemia than white people. I think it's one out of every 12 African American children carry the sickle cell trait, and one out of every about 250 actually get sickle cell. And sickle cell is something that CRISPR is can very effectively cure. So them being at higher risk and being less likely to afford it is obviously a very big problem. Some possible solutions to this. The main solution would be, in a perfect world, would be, universal healthcare. but that's very unlikely in a capitalist society like the US is in. And the best option would just be to try to expedite the development of CRISPR and the application of CRISPR, because the longer a technology is out and the more efficient you get at it, the cheaper it will become. I believe this is the case with chemotherapy, how when it first came out, it was very expensive, and it's slowly becoming more affordable. The longer it's out, the more efficient it is, and the more effective. So the only real solution we have at the moment is just to try to support CRISPR and try to expedite its development. And thank you.
Hello, my name is Hillary Marcia. I'm a part of the social aspect group. My slide focuses on how CRISPR can help people in poverty. Cost. CRISPR is estimated to cost anywhere from hundreds of thousands to millions of dollars for one treatment. This could mean that people of a higher status and income will be first in line to receive this treatment. This also could mean that patients who live in more developed countries will be prioritized. Healthcare access. Because of health inequity, there is a strong correlation when it comes to people's wealth and their health. Social determinants of health have a large impact on people's health and can help contribute to health disparities. The top left image shows social determinants of health. They include neighborhood and built environment, health and healthcare, social community and context, education and economic stability. People who deal with social determinants of health are more likely to carry disease or develop one, which is why they must have a chance to reap the benefits of CRISPR. We need to encourage equitable access to CRISPR and avoid a world where the rich have the benefits of CRISPR and the poor do not. Benefits of CRISPR in Africa. I believe CRISPR has great potential in helping underdeveloped countries. For example, the technology could benefit countries in Africa that are at high risk of disease. CRISPR could also be extremely beneficial in Africa when it comes to agriculture. According to worldvision.org, 21% of Africa's population suffers from hunger. If farmers in Africa would be able to work with gene-edited crops, could potentially help put a stop to malnutrition by reducing food shortages and developing crops with more nutritional value. Another example of it is using CRISPR to help people in Africa with diseases like sickle cell disease. So according to the CDC, sickle cell disease affects up to 3% of births in some part of Africa. The bottom left image shows the percent of the population that has the sickle cell allele with hemoglobin S. CRISPR treatment could help reduce the prevalence of sickle cell disease and save many people. The Innovative Genomics Institute, founded by one of CRISPR technology's inventors, Jennifer Doudna, is made up of researchers working on advancements in genome editing. According to their website, they have developed an experimental therapy for sickle cell disease. Since they are only in their early stages, it makes sense if they offer therapy to only a select amount of people. But I hope in the near future, as this technology continues to develop, CRISPR therapy for sickle cell disease will be available to patients in Africa where it is needed the most. CRISPR awareness. Though there might be obstacles when it comes to making CRISPR available in Africa and other undeveloped places, it is important that health inequity is avoided. These places could be helped by lowering their prices and can also be supported by fundraisers dedicated to giving them access to CRISPR. To help make CRISPR available to everyone, it is important that we spread awareness. By informing people about CRISPR, we can develop more advocacy and support for underrepresented communities. We also need to educate these communities about CRISPR so they have a chance to benefit too. They deserve to be acknowledged and their voices need to be heard. Thank you for listening.
All right, so this is the political aspect of CRISPR. My name is Timothy Alamo. I'll be starting it. So to begin, I'd like to introduce kind of why I chose the political aspect of CRISPR, just because I think it's so important. As it stands now, there's very little conversation on the political side. I mean, with the other three, with the ethical, the social, and the commercial, there is some talks of it. So I felt when I was initially picking that the political side had it was the least tapped. And so I thought that if I, worked hard enough along with my other team members, we can make like a very big, large impact. And so that kind of brings us to the current state of CRISPR. So as it sounds right now, worldwide, there's been zero politicians who've actually given a definitive stance on CRISPR, their opinions, kind of where they think regulations should go. And that's really scary because for 10 years, we've seen scientists create new applications for it. We've seen scientists kind of begin their research. We've seen scientists do things with CRISPR, and there's been no regulation on it. And this means that the technology is actually moving faster than the regulation. And that can be very, very harmful because if we don't get on top of that, um, we'll find that the companies creating CRISPR might begin to exploit it. They might begin to make it super expensive, despite the fact that it might not cost much. We'll find that they can exploit this despite the fact that it can help so many people. And so with our group, what we decided to do was we decided to actually make a letter that we can send to politicians. Um, we created a very, very, very large doc with a bunch of politicians who might be interested in CRISPR, people that might be willing to talk about it, people who might be willing to sway their opinion. And so we created a master email that kind of discussed who we were, what we believed, where we think CRISPR should go. We talked about how there was a lot of commercial implications, and that this can be beneficial for everybody, it can help all of society. And within the next few years, CRISPR will definitely be a household name. It's so powerful, it can help so many people. And so we're urging these politicians that they need to step in and try and help this regulation because, if it gets out of hand, it'll become super expensive. It won't be available to those who need it most. And so it's been really eye-opening kind of working with everybody and creating this because it's allowed us to kind of see the world of politics in a new way. I mean, we see that these lobbyists really are trying to pad up their pockets at the expense of society. And so, yeah, that's me. I know that Anna, I worked with her. I think she might have made a video. So Michael or Leda has that. I'm not sure though.
Yeah, she can go last. I have her video.
Oh, okay, perfect.
Okay, so next, Daniel and I worked on the commercial aspect of CRISPR. Now, unlike the other topics, this part of CRISPR delves into all the fields. So similar how we're talking about funding and social economic issues, the commercial aspect of CRISPR is also very important to talk about. So one example I want to bring out is the National Defense Act of 1958. In 1958, a federally funded act was introduced to focus creating more STEM-based classes in higher education for high school and college students. Now, during the mid 20th century, there's the space race, and there's a huge surplus of need for nationalism, and America needs to be the best. So by federal funding, they were able to create more aerospace classes for younger students. And because of that, we're able to see a surplus of engineers and aerospace and astronauts that we could implement as a nation. So this is an example of how federal funding educational programs for students that the US can create and inspire young scientists to delve into this new field. We see this brand new technology and not many people are talking about it. So by creating more defense acts and more educational acts to help benefit students in science in general, we'll be able to hold more conversations and hold more experimentation in the future that could benefit us as a nation. So right here, you can see that over the past 20 years, we have seen an increase in education and related programs that were federally funded. So hopefully in the future, with more conversation that we're having right now about CRISPR, we can see more funding towards STEM classes in terms of CRISPR advancement and experimentation. The next example I want to bring up is insulin. So this is another example of how what Freddie talked about, or with Hillary talked about, that with more technology that the prices will decrease. So insulin was actually used from pigs in 1922. And we were able to use pig insulin in humans. So over 7.4 Americans rely on insulin to treat diabetes. And this has been a very expensive and tedious material to use. However, in recent years, we have found that through biotechnology, we have been able to replicate human insulin. So instead of using a similar variant like pig, we're able to create an identical copy of human insulin. So this is an example of how with new genetic practices and technology, we have been able to create human insulin equivalents as well as making it cheaper. So in this slide, you see the price of unit of insulin across the markets. So over the past 20 years, they have been very expensive, and there has been a lot of talks nationally about universal healthcare and why insulin is so expensive. However, if you see around 2016, 2017, you see the unit price start to stable out and lower. This is because of the new introduction of insulin practices, and we have been able to find efficient and cheaper ways to produce insulin. So with new technology and scientists into CRISPR, we can be able to lower the prices of CRISPR that can be available for everyone around the world. So with our commercial aspect, there's two main parts that we notice. One is great market potential. Like Timothy said earlier, that we have been advancing the technology and not many people have been talking about it. So with new technological advancements, we will be able to create an open market for people who are interested in creating new jobs and interests for younger students. And our second part is just target audience. We are appealing to younger audiences, 18 to 25-year-olds, who are interested in going into this field in college and STEM courses as well.
When I began my research on the commercial aspect of CRISPR, I kind of looked at three important things. When you think about commerce, you kind of think about the market, such as products. You think about jobs, such as careers within CRISPR, such as geneticists and more. And then you also think about food, like agriculture, how this can impact other other biotic factors in the world, not only humans. So when talking about the agricultural use of CRISPR, it can be seen that CRISPR can be used to genetically modify crops at a much more precise way than using, let's say, GMOs. As I'm pretty sure Hillary mentioned, when using CRISPR, we can change food to become more nutritional. We can change its yields. We can change its tolerance to biotic and abiotic stresses, such as droughts and other topics that can be related to global warming. So when thinking about genetically engineering crops, it can be really beneficial, and a lot more money should be put into it and invested into it. As of now, on the market, there's a limited amount of CRISPR kits. And what a CRISPR kit is essentially, or one that I found an example of on synthco.com, was a kit that basically is used in sort of experimental settings, such as a classroom or just in a lab. And right now, the one that I found and I looked at was a synthetic RNA CRISPR kit, which basically is just trying to show off how CRISPR works as like a phenomenon, a scientific phenomenon. And right now they can go from anywhere between $90 to $300. That's not accessible, obviously, because not everyone has $90 to $300 to spend. Maybe scientists do, but not just a regular person on the street, like a regular citizen does not have that much money to use. So with time and in the future, as CRISPR is looked into more and more widely discovered and innovated on, the cost for making these kits can lower. And with lowering the cost of the kits, it can have much more commercial success. It can be turned into just a household object or a household experiment, like making a volcano, a scientific volcano for like a science fair. And when talking about careers, CRISPR, there's been a large spike in changes from just medicine to like being a doctor, like a primary doctor or a physician. There's been a more kind of focus on geneticists, including some jobs like genome engineers, genetic counselors, or genetic therapists. And as our world goes on, it's going to be much more imperative that there's more of these professionals, because we are living at a longer rate. But there's still like chromosomal diseases or hereditary diseases that can come about or that are already there because we are living so long. So to prevent like these deaths, we can essentially just look more into CRISPR and having more CRISPR professionals to innovate in the field. So moving on to our ethical aspect.
Hi, I'm Julie, and I decided to research curing disease with CRISPR as my topic for the ethical aspect. So, based on our research, CRISPR can be used to cure diseases such as hemophilia, sickle cell anemia, high cholesterol, HIV, Huntington disease, and could potentially be used to cure cancer. Um, Although sickle cell anemia is like the most popular thing that CRISPR can cure, it has been like proven clinically as well. Although CRISPR can be used to cure disease, many people do not have access to CRISPR, and only select individuals have access to CRISPR since it is very expensive and many people cannot afford it, which is why I am proposing a plan to start a fundraiser. Since CRISPR is only available to select individuals and is very expensive, only people with connections or money can be selected for clinical trial. CRISPR can be used to cure many diseases in the future, so I want to make it more known in the world. And I believe that not having access to cure these diseases can lead to other global issues such as poverty and unemployment. If you have a disease, parts of your life are very restricted. For example, getting a job is very hard for many people because they have a disease such as hemophilia. Therefore, unemployment rates are increasing because these people cannot get jobs or at least get a job that they would like. And as unemployment increases, this leads to poverty since there is a limited source of income in the household if they do not have a job. CRISPR should be used in order to cure diseases that can be cured so that we can prevent these issues in the future. And I believe that even though we are not specifically benefiting from this cause, I think that helping the people who can is very important. And even though if it isn't right now, I hope that in the near future we can start fundraising for nonprofit organizations or for sickle cell anemia organization and promote it with social media or the event that will be happening soon. Thank you for listening to my presentation, and I will be handing it over to Carmelin.
Hi, so my name is Carmelin Macias, and I decided to specifically research designer babies and basically the ethical aspect of CRISPR on that. So based on our research, we have learned that CRISPR for designer babies is unethical. So introducing the topic designer babies, it's basically modifying or selecting like a particular gene or removing a particular gene that is associated with a characteristic or a feature such as blue eyes, and things like that. So it's such a controversial aspect, and I think it was important to talk about this only because it's important to know just how far we can utilize CRISPR and where we have to draw the line. So its potential impact. So as promising and innovative as CRISPR has proven to be, it has the potential of eradicating hereditary and genetic disorders. However, allowing people to utilize CRISPR to choose their children's genes and features leads to the fear of like creating a genetic aristocracy. And meaning by that, I mean that no matter what, when we utilize CRISPR to change characteristics or our IQ, increase our IQs, or enhance our athletic performances, no matter what, there is going to be this. The genetically modified people will always be able to dominate, or they will have an unfair advantage over those who are not genetically modified or don't carry enhanced genomes or don't have genomes that have been deleted. So there is always that fear that that will happen. And So, which is why we will most likely draw the line on CRISPR on, well, basically we'll draw the line there, and we'll specifically utilize CRISPR to eradicate diseases and cure diseases and just improve like medical illnesses. So when is it authorized and why? Considering the unfair advantage, again, we believe that designer babies are not justified, and we should employ CRISPR only for the medical purposes, such as research and treating fatal diseases. So that basically concludes my presentation. Thank you.
Hi, my name is Samantha Graves. I'm going to continue talking about the ethical implications of CRISPR. So as future doctors, biologists, and lawmakers, we need to start taking control and having complex discussions about the applications of CRISPR. Many questions arise with CRISPR's development, including which DNA modifications are ethical and which are unethical. One of the first topics to be discussed is that the long-term effects of using CRISPR remain unknown. If using CRISPR could cause future health problems for patients, would it be ethical to use CRISPR with the mass public, or should it continue to be used for dire cases only? Another question we must discuss is whether it's ethical to edit germline or reproductive cells. If germline editing takes place, you can alter humans for generations. Should this be completely off limits, or should it be considered as treatment for some patients? Starting to think about these large pressing issues will help us establish a precedent for how CRISPR will be used in the future.
So in summary, we believe that CRISPR is something that we must act on now. It is imperative to control the conversation and get our generation thinking about this to create a better future. With vast potential and new ideas, CRISPR can be the beginning of a wider conversation. We also believe that these new ideas should be accessible to all communities and classes, such as students, parents, educators, and scientists.
We also want to give a big thanks and appreciation to everyone who's kind of gotten us here. You know, June, the Bea group, Work Wonder, Dr. Gladys, who I don't think was able to make it or isn't here, but we still appreciate her, and Michael Friend, of course. Thanks everyone for listening, and that was our presentation on CRISPR.
Well, thank you. Certainly CRISPR Uncut, wonderful job. Any questions out there to CRISPR Uncut, the team?
I have a question. I'm curious for the group here who did this CRISPR Uncut. How much did you know about CRISPR before this internship?
Personally, I've known, like, I knew very lightly of it, like surface level, essentially. I knew the word. I didn't know what it meant. I didn't even know, I thought it was like technology, like metal. But when I found out it was actually like something that's already in us, like it's just a part of a cell, I thought it was really fascinating, and that really caught my eye. And just, I learned so much more when I was doing my own research.
Yeah, it's really interesting and it changes so quickly, right? How about for someone else? And is it possible for whoever is sharing to stop sharing so we could see all of you? Thank you.
One thing I noticed is I didn't know about CRISPR, but I have never had these discussions about the social, ethical, political implications. So I think it's not always just about science. It's always about the conversation and who you're treating, how much it'll cost. So I think it was a great conversation to have with all my group members, including Michael and Dr. Gladys. And I was glad I was able to share our experiences as a group in our side presentations and what we learned.
Yeah, thanks, Christian. It's true, because it's not just the science, especially with CRISPR. There's so many, the social, ethical, political, all of those aspects that you all discussed. It's complex. And who has access? It was really interesting what you talked about on how much does it cost? Who has access? Who knows about this? And so this is why Michael and I are both very passionate about having this and having you all experience this. And so I'm just curious, from your perspective, having done this, who came up with, how did you all come up with this idea of reaching out to policymakers? And where are you with that process right now?
I can speak on that. So the initial idea was, I think I might have come up with the initial idea to write the letter. We were talking about the political implications. I was in a breakout room. I don't know what it's called in Microsoft Teams, but I was in a room with Michael, Dr. Gladys, and a few other members. We were kind of discussing what we can do to kind of reach the people. And so we all decided that a letter might be the best idea. And as it stands right now, we have the letter, I'd say like 95% done. We're very likely going to start sending out emails and maybe even written letters, I'm not entirely sure, to the people on the master list that we made. And so I'm really excited for that because I think that it can have some real world effects. I think that CRISPR is definitely going to become a household name within the next 5 years, 10 years. And when it does, I think that it would be really cool to say, hey, I helped kind of bring it where it is now.
It's true. It's really important. It's something where it's access to information, access to just understanding, again, beyond the science, but the impacts. I think it's important just to make informed decisions and for folks to know more about what kind of impact this might have on decisions as simple as whether you share your genetic material with, for example, those what is it, like 23andMe, right? I can't remember what the name of those organizations, but you know what I'm talking about, right? And then what happens with criminals, right? With the genetic materials that happen and they can find people, that it's not just you, right? It's also your whole people who are connected to you genetically. It's fascinating. Anyone else have anything? I'm just curious with some of the others who shared, how much did you know about CRISPR before this internship? Could I invite someone from the CRISPR Uncut team to also share?
Yeah, I'll talk again.
Julie.
Oh, Julie, do you wanna go? I don't mind.
Oh, it's okay. You can go.
Okay. Well, when it began, I knew practically nothing. Like Christian said, I knew the name, I knew that it existed. And then Michael actually, before the internship began, he had us watch a documentary on Netflix. I think it's called Human Nature. And for the first 2 or 3 meetings, we talked about kind of what CRISPR is. Michael made sure we had a very deep understanding of kind of like science, the proteins in our body that allows it to happen. And so, yeah, we learned a lot. Michael definitely helped kind of our understanding of that.
Awesome. And then Julie, what did you want to add?
Personally, when I started this internship, I applied for this topic not knowing what it was. But when Michael told us to watch the documentary Human Nature, I remembered that like a few months back, I actually watched that documentary by myself because I thought it would be somewhat like interesting, and I did find it very interesting, but I was still unaware of what CRISPR was, and I definitely feel like this internship has helped me deepen my knowledge and understanding of something like this. And if I can in the near future, I would like to keep like continuing on researching CRISPR and what we can do to make it more available to the people out there.
Thank you. I know there's another whole group. So Michael, does anyone else want to share before we move on to the next group? I'm going to check YouTube to see if there's any questions from the audience. Definitely have a lot of love out there. Thanks for sharing. Thanks for the comments.
Hey, June, if I could share Anna's.
Yes, please.
Because she was a part of the group that just went.
Oh, yes. With the video, right, Aleda?
Yes.
Thank you.
Welcome to my presentation, CRISPR and Politics by Anna Bispo. What is CRISPR? CRISPR is a gene editing tool that is a replication of segments of DNA needing to be changed. Cas9 is the name of the protein made to change the sequence of a DNA strand. The sequence of DNA Cas9 takes to replace the part of the DNA depends on the fix it intends to do. How does CRISPR affect life? CRISPR is currently being researched to see how and if it can cure cancer and many other microbial diseases. CRISPR and the logistics of its capabilities are being debated in the media, and the topic of many ethical, social, and political issues. One of the examples of how the image of CRISPR is distorted in politics is when some of the arguments of the ethics of it first arose in public conversation. CRISPR's capabilities concerning the idea of disrupting the human genome disturbed the public. For example, designer babies. What can we do about CRISPR's reputation? Science has to take charge of the conversation in mainstream media. More research has to go into CRISPR, and what science can actually do with it safely. And CRISPR needs a lot more testing. It is a gene editing tool after all. What Bea Group has done so far, we have started writing letters to government officials urging the importance of CRISPR to be displayed correctly in mainstream media. There's a list of senators, governors, and House of Representatives on the slide, and a draft of our first letter. What we've learned from our internship experience. We've planned our events for late September and for the whole internship. We've learned to gather research for our papers and organize them properly. And we've talked about a lot of issues concerning CRISPR and the controversy surrounding it. Conclusion: science and CRISPR are fun and interesting. Our government has priority issues. More funding needs to happen in STEM research organizations and labs, and this has been a very fun and educational experience. Thank you for having me, and have a good evening.
That's awesome. Thanks, Leda. All right, Michael, shall we move on to the next group?
All right, absolutely. Definitely hearing from the future, and I tell you that these young people are determined, as I am, to ensure that they're a part of these discussions moving forward. So thank you again, CRISPR Uncut team. Now let's hear from Career Day team, which was a few leaders there. And I want to turn it over to, and let's start. I would change order just slightly. Start with Sarah. Will go in this order. After Sarah, there'll be April, Marianne, Juliana, Michael, Zachariah, and Elisa, and followed by Leza would go last. So thank you. If Sarah, you can go now and share your screen. Excited to hear from you all. Career Day.
All right, I'm gonna share right now.
Thank you.
Can you guys see it? All right. So Zachariah is gonna start us off.
Yes. So, hi, I'm Zachariah. I co-led the team with Sarah E. and Alyssa, and this is our presentation for CRISPR Career Day. So to start us off, we'll do a table contest just to know what we're going through. So firstly, we'll be describing the purpose of the event, like going through an overview, then what we'll cover during the event as our agenda, who will be attending, and what guest speakers we'll have that will share what they know about CRISPR and how we're planning on marketing the event. So the purpose of Career Day is, well, at its core, it's a virtual event that focuses on exposing the basics of CRISPR to the newer generation of students who are interested in working in the scientific medical field. We plan on introducing them to medical professionals and scientists that are adapted into a CRISPR environment and are willing to share their experiences. In the event, they'll discuss an array of topics like their experience working and how they're introduced to it, pay, education, skills, etc. By the end of this event, we want people to have gained a better understanding of how CRISPR works and what it is and how they can be a part of it in their future.
As of now, here's the agenda we have created, which consists of discussing the intended uses, purposes, and inner workings of CRISPR. We will also allow companies to introduce projects they have worked on in the past, exposing students to CRISPR's potential through breakout sessions in specific categories, which consists of the political, social, commercial, and ethical aspects that we have seen the previous group discuss, as well as introduce a pathway for students to study the ins and outs of CRISPR, and then finally allow students to be able to actively engage with CRISPR professionals through panel discussions and lightning talks.
So here I put down who we expect or we want to come to this virtual event. I made a graph as well. So we primarily wanted to target students because they will play a vital role for the future of scientific and medical research in CRISPR, and along with bringing light to new topics of conversations. Then we have faith-based organizations to gain perspective from what these communities think of CRISPR. And then we have pharmaceutical companies and also biotech companies, just in order to gain a better understanding of how CRISPR works and how they have applied CRISPR to their industries. And then we put also we want 10% just miscellaneous, like parents, student driven organizations, teachers, and ultimately this whole audience, we just want to get their opinion. And yeah. So potential guest speakers, here I wrote down Barbara Ferrer, the LA County Public Health Director. Then we have Feng Zhang, he's a CRISPR scientist. Then we have Anthony Fauci, he's the Chief Medical Advisor for the President of the United States. Blanca Pacheco, she's the Downey Mayor, and then college professors. So really what the goal here is to get a wide range of high position people that have some sort of understanding of CRISPR, and we just want people to get more comfortable of integrating CRISPR into our society. And these people, they have high positions, so they're very people are going to trust them. And also I specifically put the Downey Mayor just because we have such a large amount of Downey interns participating in this internship. So I kind of wanted her because she, people are a lot more comfortable. They have somebody to trust. And yeah.
So our group found it really important to obtain a wide audience. So to do that, we'll have to market our project pretty well. So in terms of marketing, we looked at reaching out for sponsorships and collaborating with companies, creating e-flyers to promote our event, emailing school districts to relay information over to their students, which is really important for our new generation to be knowledgeable about this subject. Creating a website and utilize widely used social platforms such as Instagram and Facebook to gain more attraction, especially since it's so easy to share information on those platforms today. And also establishing a budget to gain a larger audience so we can do things such as giveaways or making new posters. So we also found it really important to have an agenda for that day, so our audience wouldn't leave with more questions that they came in with and that they can leave informed. So for our audience's need to know, we wanted to discuss how you can specialize in CRISPR and careers surrounding that technology, as well as the wide range of companies that partner with CRISPR and how it's impacted them. And it would be nice to discuss, given the time, if we could also have companies discuss how they discovered CRISPR and such, as well as opportunities in internships today and clinical trials and controversies.
So the whole point of this event is to get students career ready. Beta Group has successfully prepared students across California school districts to work in a professional environment. So our goal as well in this event is to do the same with CRISPR. We want younger generations to start familiarizing themselves with CRISPR technology and explore its possibilities. We want those who are curious and excited to learn to initiate important discussions around the future of CRISPR. And finally, this is our flyer we made for the virtual event. And that's pretty much it. So now I'm going to go on to my presentation. So I focused on the ethical implications of CRISPR. So CRISPR's capability. With this new emerging and innovative biotechnology, it means that basically scientists and medical professionals can now use this tool to create cuts in DNA that had been previously impossible by other technologies. It has the power to cure diseases, enhance agriculture by designing crops to have desirable traits, and create better therapeutic treatments for untreatable diseases like cancer, HIV, AIDS, and other genetic disorders. In Bill Gates' article, Gene Editing for Good, he emphasizes the impact that CRISPR will have specifically for underdeveloped countries, where people and children are dying of preventable causes such as malnutrition. He makes a point that with CRISPR, these small communities will be able to farm better cows, enhance their milk production, and improve the productivity of their crops. Specifically in sub-Saharan Africa, 60% of people make a living through their land and crops. Therefore, CRISPR will allow their crops to be more abundant and adaptable to climate weather. So this is a quote by Dr. Francis Collins. He says that gene editing itself is not neither good, bad or good. It depends on its application. Like he said, I think in general, CRISPR is a step up to prevent diseases and treating patients and furthering medical research. But it has also been called to attention the negative implications that this technology can have not only for humans, but other species of the environment. And many people are starting to question to what extent will this technology go. So on this slide, I wanted to talk about the difference between germline versus somatic gene editing. And so basically, somatic cell gene editing refers to disease-causing DNA. And so what's so exciting about CRISPR is that scientists can now make precise changes to the DNA code inside live cells. And in this particular case, individuals who are being treated by CRISPR will be impacted specifically, but not their future generations. And so sickle cell disease and cancer will be treated when it refers to somatic cells. And germline editing, basically, this is what kind of is so controversial with CRISPR. Here, many scientists have expressed their hesitance and need for regulations, and editing the germline refers to the modification of an egg, sperm cells, or embryo, which will be promptly passed down to future generations. So the reason for such public concern over germline editing is mainly the whole idea of designer babies. And this phrase has been thrown around for a while now, and it probably frightens many people because it goes against the whole the traditional ideas of reproduction. And because we are not accustomed to this idea, we start to question as a society what this could mean for our future. And for many scientists, there's also this other concern that because of such a limited understanding of this new technology, if they do go forth with germline editing, there could be off-target activity or unintended mutations. And some other concerns of CRISPR are access to CRISPR applications and a lack of understanding from the public with, like science. Okay. So here I provided this article of basically there's this Chinese scientist who went forth to creating a human embryo, which is germline editing. And the outcome of this project was unsuccessful as the mosaic effect took place, meaning that not all of the cells being targeted were necessarily edited. And the team of scientists also said that there were off-target modifications. And here I just put a quote. It says from a David Baltimore, and he says that it shows how immature the science is, and we have a lot to learn from their attempts, mainly about what could go wrong. Initiating conversations and bringing in perspective. We want to bring in people, even if they know little about the topic, and get them to the point where they can engage in meaningful debate. So I think it's the perfect time to start conversations surrounding CRISPR applications. And as a society, we need to come to terms to how far we will go and to what length this technology should be used. Although we are still a long way from, in the United States, as it's illegal, we can't really create designer babies, but I think it's still imperative to start discussing the possibility of this happening in the future. So I think we should, as a society, we have to bring in people from, marginalized groups, from diverse backgrounds that work different jobs, especially students, and just so we could have a starting point on what we want to see in the future. Also, another topic I'd like to just promptly mention is that we also have to bring down stereotypes or misinformation surrounding types of technology like this, especially surrounding the African American community, because CRISPR is going to be used for like sickle cell anemia, and it was heavily emphasized. Since Black Americans are also, they're the highest group of people that have sickle cell anemia, a lot of them are very hesitant and skeptical to go into these, medical research or like trials because of previous experiences, like the Tuskegee experiment, where the participants in this medical experiment were not informed. There's no like consent, and they never got the treatment for their illnesses. So it was deemed as very unethical. So if we want CRISPR to have a positive impact and treat people with sickle cell anemia, we need to find a way for Black communities to get involved and break down these medical barriers. And that's all.
Thank you so much from the team. Certainly, CRISPR Career Day, Career Day team. Very exciting. You all did a very good job of presenting. And before we move forward with the other interns, just want to make sure we hear it from everyone as far as the team. You all got together and presented as a group. Got together and presented as a group. And so now I know Aliza did some work around political, and also Zachary also did some work as well around the area of choice. Each intern had to choose one of the 4 areas. And so, Aliza, was there anything else you wanted to share around the political aspect before we move on to the other group, the other members in the group?
Yes, I did prepare a presentation for the political aspects of CRISPR. I'll share that right now.
Thank you.
Can you guys see that okay? Yeah.
Yes.
So I'll be presenting the political aspects of CRISPR. I'm Melissa again. So today I'll be discussing how to obtain legal approval regarding research and marketing, current laws and regulations affecting CRISPR research in the United States, and finally, the importance of regulations on a national and international level. So approval for studying and marketing CRISPR. For studying in the United States, clinical studies of gene therapy in humans require a submission of an investigational new drug application, also known as an IND, before initiating the project. And for marketing, the technology of this nature requires the submission and approval of a biologics license application. Who regulates CRISPR? In the United States, as of today, the FDA Center for Biologics Evaluation and Research regulates CRISPR usage in the United States. The FDA considers any legal use of CRISPR to be gene therapy. Examples of this include treating infectious diseases such as sickle cell disease. A gene therapy for market has not yet been approved, which includes the sale of self-administered gene therapies. Regarding the usage of CRISPR in agriculture, there is no national or international agreement on how it should be regulated. As shown by the charts on the right, the regulations on regarding CRISPR technology widely vary depending on the country. So as you can see, the countries in red right here are heavily regulated, and the ones in green are less regulated. Though the science is becoming global, there are currently no minimum international standard for regulations. After conferring with a few of my deep dive peers in LEAD, we realized that very few officials, or mainly 0, have spoken out about the CRISPR technology altogether. So this is why officials should begin creating regulations. The technology is rapidly growing to ensure public safety and to prevent the exploitation of CRISPR. Our group came to a consensus that people like us need to urge these officials to start the conversation, especially regarding regulations on this technology. So together we began drafting a letter, which is shown here, with the goal in mind to start a dialogue with politicians and officials, as well as raising their awareness on this matter. And this is my works cited, and thank you guys for listening.
Thank you so much. Let's hear from Zachariah. I know Zachariah's focus was around commercial, and so if you had anything.
Yes.
Absolutely. Go ahead.
Okay. So I'm Zachariah, as you before. And so I focused on the commercial implications of CRISPR. And so I'll be talking about the basics of CRISPR and how it'll be implemented commercially and how Career Day can help impact the commercial implications. So as spoken about already before, the definition of CRISPR is a genetic engineering tool that uses CRISPR sequences of DNA and is associated to its associated protein to edit the base pairs of genes. So of course the cost is really expensive, and therapies are close to $1 million. But our goal is to allow CRISPR to become accessible to everyone. So the mission and vision for the commercial implication of CRISPR is to reduce the cost of CRISPR therapies in order to provide treatment to everyone who needs it. And so I believe it was, as Freddie said, from the CRISPR Uncut, that the longer medicine is around, the cheaper and more affordable it will become. So our vision is for CRISPR to be available and affordable to everyone in the near future. And so from our Career Day presentation, we spoke of the newer generation of students becoming more exposed to CRISPR and being able to share their thoughts and their ideas on how we can understand the future of CRISPR under an economic standpoint. in order to make our vision become a reality. Thank you.
Thank you so much, Zachariah. Thank you to the team. Career Day job well done. Thank you so much. Great job. Let's move forward. Now we're going to hear from members of your team. Let's start with April. You're up next.
Okay. Can you see my screen?
Yes.
Okay. All right, so my name is April, and I did research on the ethical implications of CRISPR. So I wanted to start off with this quote: CRISPR has the potential to transform the world, yet the ethical cloud of human modification overshadows these conversations. I think this really relates to my topic, and you'll see why. So how do ethics relate to CRISPR? Because CRISPR is just now starting to emerge in more scientific and medicinal research, there are a lot of different opinions on it. And my position on whether or not it's ethical is that it really depends on how it's used. But everyone has their own moral judgment and reasoning. So I think it's important just to share some of the pros and cons so that people can form their own opinions on it. Okay, so starting off with some of the pros. The biggest one is that CRISPR can save lives, and it has the potential to do that. Last year, the FDA approved a clinical trial to treat people with sickle cell anemia using CRISPR, and so far it has been successful and has cured several patients. This is really good because approximately 5% of the population contains genes that carry sickle cell anemia, and in the US alone, it affects 100,000 people. Without CRISPR, people with sickle cell anemia usually die early in their 40s, but the positive outcome of this trial gives people hope for the future. And there's still research being done, but scientists expect that CRISPR will soon be able to be used to treat other genetic diseases like diabetes, cystic fibrosis, muscular dystrophy, cancer, and more in the future. So obviously CRISPR can do a lot of good in the world. However, there are a few cons that I think should be addressed. One is that CRISPR is pretty expensive and not everyone has access to it. So there is the risk that it would only be used to treat wealthy elite people, which wouldn't be fair to everyone else. Also, while CRISPR has successfully cured people, it's not yet 100% effective, and there are risks of having something called an off-target effect, which is when the CRISPR doesn't bind to the correct DNA strand and it causes an unintended effect elsewhere, which can have significant consequences. Furthermore, with CRISPR, there's always the risk that people will use it for unethical purposes. The term designer baby has become pretty common because of a controversial affair that occurred a few years back when a scientist, the man that's on the screen, he genetically modified the embryos of twin babies. He did this in order to get rid of an HIV gene that they had, but he faced a lot of scrutiny for this because CRISPR wasn't well tested at that point and it could have been unsafe. So he faced 3 years of imprisonment for this. But what this whole affair really did was it showed people that people can use CRISPR for germline editing, which is when you edit the genes of an embryo. And this brought about a whole new set of risks involving eugenics because people can now use CRISPR to create babies that have been genetically edited to have desirable traits. For example, perfect vision or whatever high IQ it says there. And this is dangerous because there are people with questionable morals that'll use CRISPR for their own personal interest. Okay, so that's all I have for the pros and cons. And I think that it really leaves the question of what can be done with with CRISPR, and I think that there's some steps that need to be taken. Like we need to come up with some sort of social consensus on what's ethical and what's not. And also there needs to be some form of political regulation and laws put in place in order to ensure that like the ethical boundaries are not crossed. And there's two more. Okay. We need to make sure that it's commercially accessible to everyone, no matter their like race, status, wealth, or other factors, so that there's equal opportunity and everything is fair. And finally, I think that there definitely needs to be more research and testing done to make sure that the technology is really effective. Okay, that concludes my presentation. These are some of my sources. And I just want to say thank you to everyone, and I'm looking forward to continue working on Career Day.
Thank you so much, April. Next up is Mary Ann.
Hello, my name is Miriam, and this is my presentation for the CRISPR internship of summer 2022. So we first learned about CRISPR by watching the Human Nature documentary, and we also participated in discussions. And so this gave me a better understanding of the different perspectives about CRISPR. And I knew about it a little bit before, but it was mostly about like designer babies. And so this gave me a better understanding and more examples of how CRISPR can be used. And so we got to choose from one of the following topics to focus and do more research on, and I decided to do ethical. So when I did ethical, the different applications that I learned about was in the medical field, they can be used, CRISPR can be used to help patients with life-threatening conditions such as sickle cell anemia. And it can also be used in organ transplants, like let's just say to remove diseases before transplanting it into the new patient. And so it can also be used in agriculture to make pest-resistant crops and increase yield and quality to help fight world hunger. So I think those all relate to ethical, as well as making livestock that is resistant to diseases. And also it can be used for research to help us better understand DNA. So there's also controversies that surround CRISPR, like ethically, these are because CRISPR has a lifetime impact and can even be passed down to future generations, as well as designer babies, because these are just phenotypic traits. And there's also like the question of how will CRISPR be distributed and would it be accessible to everyone? So these all led me to writing my position statement, which is I believe ethics are the most important because they provide a basis for all other categories to be built upon. By establishing ethical principles, political regulations can be made based off of them and then commercially distributed. And socially, they can be given to people who need them. CRISPR has a lot of potential in many fields. Ethics play a big role in deciding what CRISPR will be used in, and it has the potential to transform the future of medicine, agriculture, and research, as well as help improve many people's lives. It can be either used to cure them from diseases, or it can be unfairly used on specific people that don't truly need this technology. So my takeaways from this is I have a better and more in-depth understanding of CRISPR, and also helped improve my research skills because I expanded to using multiple platforms, not just reading articles, but I also watching the documentary and also like watching videos to have a better understanding. And and also I also gained new skills for the virtual workplace, and I gained more experience in my professional skills and teamwork skills when working on Career Day. And so Career Day really helped me with these skills because we worked on planning and we used organizational documents to help provide our purpose, our goals, and how to achieve it. And I'll definitely be taking these in the future. So thank you everyone for watching.
Thank you so much, Marianne. Wow, it's exciting. Next up is Julianne.
Hi, let me share my screen real quick. Can you guys see my screen? Okay. Hi, my name is Juliana Arias, and I will be presenting the CRISPR, the social implications. Oh, sorry. So what are social implications and how is it related to CRISPR? Currently, CRISPR faces controversy over its research in genetic and editing of embryos. However, I wanted to present other uses for CRISPR in society and the success that they have today. CRISPR's usage can expand from agricultural to extinct animal research. Some big names in this area are George Church and Ryan Fellon, who has a company called Revive and Restore. George Church and Ryan Fellon continue this research to revive extinct animals such as mammoths. Other uses of CRISPR can be used to expand space exploration by genetic modifications of astronauts to lower the risks of radiation. CRISPR even has the potential, as mentioned previously, to modify agriculture to withstand climate change. And with more research, this can be more accessible to families in the future. CRISPR has had the most success in the medical field, especially in areas such as sickle cell disease, as my fellow interns have explained in their previous presentations. However, there are also other uses that CRISPR has been benefiting in the medical field. Luan Yang and Jennifer Doudna are research scientists that focus on this aspect of CRISPR research. Luan Yang is a co-founder of eGenesis and works on recreating new methods of transplants called xenotransplantations, which is where they genetically modify organs from animals to be able to be used in humans. And as previously mentioned, Jennifer Doudna is one of CRISPR's most essential research scientists, and she works on gene editing and works on bettering medical research for CRISPR. And after researching these uses for CRISPR, I'm excited to see how research has grown in the Career Day, that event that will go place in November. Thank you.
Thank you, Juliana. And next up is Michael.
Can you guys see the screen?
Yes.
Hi, my name is Michael Cerezo. I am part of the CRISPR team, the Career Day, and I'm a Downey High School intern. During the first week, we watched a Netflix documentary called Human Nature. In the film, they talk about CRISPR technology, one of these techniques being Cas9. Cas9 is a protein that makes the cell immune. It does this by copying a single strand of RNA from the virus, so that when the virus invades and sees that the DNA and when it invades, it sees the DNA from the virus has the exact copy of the RNA, and it just cuts it. In Human Nature, we also learned about a kid named David Sanchez. He had sickle cell disease, not allowing his body to transfer enough oxygen throughout his whole body. It takes away from CRISPR internship. During the internship, I've learned more and more about what CRISPR is and what CRISPR can do. We also learned that CRISPR can be dangerous. Some examples can be modifying the genes of babies, making them CRISPR babies. CRISPR babies are when the parents decide to modify the DNA. Some examples are changing the eye color, changing the hair color, changing the nose, and etc. Another example is using CRISPR in the military to make them stronger, allow them to make faster decisions, and etc. Political statement on CRISPR. Even though CRISPR has benefits such as curing medical conditions like Alzheimer's, cancer, strokes, STD, blood disorders, and etc., it can also be used to modify people's DNA, even though they don't have any medical conditions, which can be a problem later on because there will be more people that will use CRISPR on themselves to modify their genes instead of using it to heal medical conditions. To make sure that this doesn't happen, we must make sure that we have a safe future with this kind of technology. We must set standards such as making sure that people who need their medical conditions healed to be top priority and making sure that it's easily accessible. And that's done.
Thank you so much, Michael. And I believe next is Lisa.
Yes. Hi. I'm just gonna share my screen.
Thank you.
Okay. Can you see my screen well?
Yes.
Yes? Okay, thank you. So I'm focusing on the social aspect of CRISPR. Here is what it's going to be talked about. What is it? Why are people concerned? And what does this do to us? What are the social aspects of CRISPR? For the most part, many of the social aspects of CRISPR have to deal with concerns of the genome editing. Since CRISPR is beginning to be used for many reasons, people have found it to be concerning. One of the main uses would be the application of this genome editing technology found in animals. How is genome editing being used on animals? And the short answer to that would be veterinary medicine. The reason for so much concern would be the fact that many people are not yet informed about the different uses of CRISPR, and the FDA and CVM have supported the idea and potential of genome editing. Why are people concerned? The concern for genome editing has come up because people are not informed. CRISPR is very new and has been briefly taught or not taught at all in the classroom. Another reason for concern would be that many people view CRISPR as something that could be used in negative ways, which is very true, but the main purpose is to create medicines, cure illnesses, and etc. What does this do to us? So with the rise of concern also comes people who don't fear the use of CRISPR. Rather, genome editing helps others feel included. At times, we are faced with the struggle of insecurities, and this comes from disliking the way we look. And some people turn to CRISPR to help them deal with these insecurities. Although genome's editing's main purpose is to help treat disease, many people look at it as a way to better their appearance. Thank you. Sorry.
Thank you so much, Lisa. All right, and I believe that would conclude both the CRISPR Uncut and Career Day. I believe we got through all of our presentations. I wanted to move now to see if there's any questions out there anyone may have regarding Career Day, or maybe direct a question directly to one of our interns or even the team.
Thanks, Michael. Actually, we have someone from Davis here. Gary, are you in a place where you can say a few words?
Yeah, can you all hear me?
Yes.
Okay. Gary Pearson, I'm the Career Technical Education Grant Specialist for Davis Joint Unified School District. Been traveling today. My day started at about 6 o'clock this morning in a garden, and continuing throughout the morning, and then just transferring down I also worked for UC Davis for 37 years. I am not a research scientist, but I work closely with research scientists that handled very complex plant systems. And one of the technologies that came into vogue and into play was CRISPR. CRISPR technology, in my opinion, is a very transforming type of genetic modification and has proven time and time again that it is a valid enterprise to enter into. And all of you have alluded in your presentations about the social aspect, about people's perception, both from the human and also the animal. From what I've seen in CRISPR is a very safe technology and proven itself time and time again. So kudos to all of you in your presentations, I should say. And hopefully from all of this, that the key things that I keep hearing over and over in the presentations that I've heard is collaboration, networking, and you've all done that quite well. You've done your research, and I can see that throughout the presentations that I've garnered. So kudos to all of you, especially the kids from Davis Joint Unified School District. I manage a lot of grants and funding that goes to support all of those career pathways. So that's all.
Thanks, Gary. Let's see. Does anyone have any questions?
Yeah, I do. This is to the whole panel. In all of your research, did you come across any discussions about the importance of disease resistance in plants? And also related, second question is across multiple species, because CRISPR can modify species, and that's a concern for the general public that doesn't understand CRISPR. So my question is, in all of your research, what did you run across as far as plant-related research?
Personally, what I have looked into with Daniel in terms of plant related is that there's a lot of practices in terms of plant modification. So for example, GMOs are a version of plant modification. Yeah. But the thing is, there is a lot of pros and cons to GMOs. So with the introduction of CRISPR, we've seen more efficient and more widespread effects on plants and crops. So for example, you could find certain genes in plants about drought resistance and apply those to any plant you want. So you see a more effective and way more like direct path to plant resistance and plant efficiency. Yeah.
And a follow-up question, would you consider being a researcher in plants?
It's actually what I want to major in, mostly botany and bioengineering.
Fantastic.
So a big part of CRISPR is not just medicine, it's all about agriculture.
Yeah.
Especially when it comes to, global shortages of food and droughts and disease. So there's a lot of CRISPR talk that is agricultural as well.
Yep, UC Davis does a lot of that work. There's a lot of colleagues that are there that do a lot of that work. I'll say that.
Thank you for the question.
Yeah, anytime.
I have a pop culture question. I'm just curious how many of you have seen the film Gattaca? Not yet. So April, you're nodding. What did you think about the film? It's pretty old.
Yeah, we watched it in elementary school. So I don't really remember, but I do know that it has to do with like genetically modifying people because they had mutations. So
Well, it was the whole premise of the film, if you haven't seen it, is a society where everyone is modified and what happens to those who aren't and what happens. So if you haven't, it might be of interest. We actually recently had our whole family rewatch. My husband and I have seen it, but our kids hadn't, so we had them watch it. So I'm just curious. Anyone else heard of the film or seen it? Not yet? All right. So moving on, other question I have for you is, oh, go ahead.
Yeah, June, if you're a Trekkie, there is one episode in the original Star Trek that deals with genetically modified people. So just a little information. Sorry, go ahead.
Oh, it's not just one episode.
There's
They made
more
a whole
than one?
movie about it.
Yeah, I know.
Yeah, not
It's
to
called-
spoil a movie from 1988 for anybody.
Yeah, and there's a thing called Khan.
Anyways, you can see we have, yes.
So I was wondering, what how do you feel the public will respond to this once this does become something that is a day-to-day thing that people are more conscious about? I feel like right now CRISPR is well known within maybe investing circles, maybe within scientific circles, maybe some people in academia are learning it, but just in general, if I was talking to someone about CRISPR, they would think I was talking about something in my refrigerator. So, but there's a lot of philosophical and emotional baggage that goes along with this. So, how do you think various segments of society are going to handle this, and what are your worries?
I can speak on that.
Oh.
You can go ahead if you want.
Okay. So I definitely think that many groups can act negatively towards the topic since it is a very sensitive topic. Like if it is available to those that are wealthy and they use it for editing babies and editing embryos, then if it is projected to the public, then some people might want access to edit their babies or edit their embryos. And another part of society might actually be more, I wouldn't necessarily say accepting, but more understanding of CRISPR and its uses to cure diseases rather than doing unethical things like trying to create the perfect baby and making it excel in different types of subjects and stuff like that. And so I definitely think that as it does get more spread out and people get to know more about it, a lot more people will take advantage of CRISPR in order to do things like unethical things, as well as many people are trying to use it for curing diseases too.
Timothy, what did you want to add?
What I was going to say is the way that I see it is initially, I really think that there's going to be a lot of pushback. I think that people are going to see the media headlines. They're going to say, oh, geneticists can do this and this and this and this. And people are going to be like, oh, it's so unethical. It's not good. People won't be able to see kind of the commercial uses for it. And I think slowly as we integrate it into our pharmaceutical and medical areas, people will begin to open up their eyes and say, okay, these headlines are really just there to scare us, and it's a good thing because overall, I really do think it's a good thing. Like Gary was saying earlier, time and time again, it's shown that it's beneficial. It can help people. And so I think at first there's going to be a lot of pushback because that's just kind of like the media does, likes to glorify these kinds of things. But I think after a few years, people will kind of accept that it's a good thing.
I think the hard part about this conversation is just the point of misinformation. So for example, when we're talking about designer babies, we're talking about traits such as skin color, eye color, hair length, hair texture. So for example, your skin is composed of over 360 genes. Currently, the maximum amount we have edited, which is very recent, like last month, is 50 genes. So at the rate in which people are in fear of, oh, we're going to create designer babies, we're way behind that. So it's at this point where we want to cure single gene diseases such as sickle cell anemia. So for me personally, I don't fear as much of the effects of designer babies, but I do fear that people use that argument in terms of like, we're not even there yet and it's very dangerous to do that. So it's not a relevant argument or conversation to have yet. Versus sickle cell anemia, where it's one gene where we can identify and fix it. So I think it is important to learn that this science is advancing slowly, but at the same time, we're going to reach a point where we can edit these features that are polygenic and are a huge amount in our bodies. So I think it is a very interesting and complex conversation to have in terms of how many genes can we edit at once and what's the boundary of too many.
Yeah, and just a comment, they've roadmapped the genome of wheat, which actually is a world commodity. A lot of research done on that, and so they've mapped it. And some of the cultures that I'm aware of, they've actually mapped hot peppers and peppers, and it's fascinating what they can figure out. So it's there in the nature of research, far advanced beyond this conversation.
Well, you all touched on the difference between when you edit something that goes into the germline versus ones that don't. So that distinction, right? Did you know about that before this internship?
Personally, no, I didn't know like much about it. So I had to do my own research and like read articles to know what like the difference was. So it was really like just interesting and to see how CRISPR can be used.
Would you say that's a big part of the controversy is, for example, that conversation about designer babies is because it would change a genetic line, right? It's not just one person. It would actually be inherited moving forward.
Yeah, exactly.
And another part of that too is when you're talking about germline editing, it's like, okay, we want to change all the eyes to blue for the next generation versus curing HIV in a family. So it's like, what's the point of like phenotypic features versus diseases in germline? So we actually, in the documentary, you see a change of stance of germline editing. So in the 90s, a lot of scientists were very against germline editing, whether it was for diseases or phenotype. However, in recent years, you see a lot of parents speaking out towards germline editing and saying, we take this stance because my child is going through this horrible disease and is in pain, and I would do anything to stop it. So I think it is a good conversation to have with just the general public who experience these things.
It really is. It's certainly something that I did not have when I was, I learned about it because of partners that we had. We had worked with Harvard Medical School for a while. They were a client of ours, the personal genetics education program. And then that's how we met Michael from his organization. So it's great just to keep learning. Anyone else want to share about just what did you get out of this internship? If you could say one takeaway from this
Personally,
internship.
I being a team lead, I kind of jumped, like I was like, I've never been like much of a leader. I'm very like shy. So I just took the opportunity and I really loved it. I learned so much on how to communicate with people and just get people involved and make sure, everyone's doing something to, make the project come together. So I really enjoyed working with Michael and Dr. Gladys. It was really interesting. So yes.
That's awesome. Thank you. Anyone else want to share about one takeaway from the internship? Maybe Alyssa.
One takeaway I had from this internship was I felt like it was very heavily focused on making connections with people. For example, I was studying the political aspect of CRISPR, and we found that there wasn't a lot of officials talking about this topic. So we try to make connections, we try to initiate a conversation. And being a team leader myself, as well, along with Seti, we both found it really important to communicate to our team members, to Lita, and to our deep dive leaders, Michael Friend and Dr. Gladys.
That's awesome. How about one more person share?
I think that from this internship, I thought it was a really cool experience to kind of, because for me, I've always wanted to look into science as a career. So being put in this group environment and working with a team, and like also like Alyssa and Sarai said, being a team lead, it was really cool to be able to just communicate with everyone and see everyone's progress on their own, but also as a team. So it was kind of really cool to see everything come together, come along. And yeah, I'm just really proud and happy with everyone's work.
Yeah, and I definitely want to celebrate all of you. Michael, do you have any final thoughts before we say goodbye on the live stream?
Certainly. Well, thank everyone, and I know we're going to celebrate shortly, but I just want to make this very important statement that next generation CRISPR project this is the future, and I'm so proud of the way that the young interns are harnessing these very complex conversations, and I can see where we're going to make like a huge turning point as to how information is shared publicly, because it's not so much as the information, but it's more who's the messenger is. And given the fact that listening to the interns speak in a way and study and come back with the points, and I've heard from a lot of professionals, I have to tell you that I'm very impressed with the interns and their work and their involvement and just their own thoughts. And so I'm looking forward to seeing how this conversation is going to move throughout the not just the district, but other school districts as well, as we take on these two very important events, CRISPR Uncut, the virtual as well as the career day. So thank you all so much. Thank you for our co-designer, Aleda. Appreciate you so much, and great job. Couldn't have done it without you. And thank you, June, as well as the school district for making this opportunity possible.
Yes, thanks everybody. And we're gonna follow up with all of you, with Michael, about how to support you, those of you who want to continue with making sure these events happen. So Michael and I have talked a little bit about that. So Michael, let's definitely reconnect about that and get and connect with everyone before the end of this week about next steps. So interns, please stay on the Zoom. Those of you watching on YouTube, thank you so much. This concludes our 11th deep dive showcase. And so tomorrow we have 4 more. Maybe this is 12. I've lost count. So we have 4 more tomorrow. There were 16 in total. And so tomorrow morning we start with blockchain at 9 a.m. Pacific time. And then we go into social media and event management. That is at 11, and 2 p.m. environmental justice design. And then finally, our last one is at 4 p.m. with business and entrepreneurship. So thanks everyone for watching, and I'm going to turn off the live stream. Please subscribe. So youtube.com/Bea Group. Thank you all. And we